Structure of hydrogen peroxide. Hydrogen peroxide is a non-planar structure because both the OH bonds do not lie in same plane. Each oxygen is sp3 hybridized. The molecular dimensions in gas phase and solid phase are different. In gas phase, dihedral angle, that is the angle between OH planes, is 111.5 degree, whereas in solid phase it reduces to 90.2. The bond length in gaseous phase is OO bond is 147.5 picometer, whereas in solid phase is 145.8 picometer. OH bond length is 95 picometer in gaseous phase and 98.8 picometer in solid phase. This bond angle HOO bond angle is 94.8 in gaseous phase and 101.9 in solid phase. So this is the open book structure in gas phase and solid phase of hydrogen peroxide. Chemical properties. It acts as oxidizing as well as reducing agent in both acidic and basic medium or alkaline medium. Simple reactions are described below. Ferrous ion gets oxidized to ferric ion in acidic medium with the hydrogen peroxide. So color from pale green will change to yellowish brown. Lead sulfide, lead paintings become black after some time due to exposure of H2S. It can be made white again by adding hydrogen peroxide. So hydrogen peroxide oxidizes lead sulfide to lead sulfate, which is white plus 4 water is formed. Reducing action in acidic medium, 2MnO4 minus in acidic medium and react with hydrogen peroxide, colorless Mn plus 2 is formed, plus 8 water are formed, plus 5 O2 is formed. Hypochlorous acid react with H2O2 to give HCl plus oxygen plus water. So water plus HCl form hydronium ion and chloride ion. Oxidizing action in basic medium. Ferrous ions are oxidized to ferric ion in basic medium by H2O2 OH ion. Mn plus 2 is oxidized to Mn plus 4 by H2O2 plus 2 OH ion will be formed. Reducing action in basic medium, iodine will get reduced to iodide ion in basic medium by hydrogen peroxide plus oxygen will be formed, and KMnO4 in basic medium with the hydrogen peroxide will change to MnO2 plus oxygen will be formed plus water will be formed plus OH ion. That is basic medium, its reducing action. Properties of hydrogen peroxide. Pure hydrogen peroxide is a pale blue syrupy liquid as it is more associated through hydrogen bonding than water. Pure hydrogen peroxide is weakly acidic, and while in aqueous solution it is more acidic than water. A concentrated hydrogen peroxide is used as rocket propellant because it can give hydrogen as a fuel and oxygen as oxidizer. Hydrogen peroxide is an unstable liquid. It decomposes into water and oxygen on standing or on heating, hence it is stored in wax-lined colored bottles, wax-coated colored bottles having a small amount of phosphoric acid, glycerol or acetonolide. These check the decomposition and therefore act as negative catalysts. Decomposition of hydrogen peroxide is catalyzed by platinum, silver, copper, MnO2, etc. and even silica present in glass bottles. Therefore, it is not present in directly glass bottles. Either they should be kept in plastic bottles or wax-coated glass bottles. These catalysts are positive catalysts which increase the rate of decomposition of hydrogen peroxide. The oxidation number of oxygen in hydrogen peroxide is -1, which is intermediate between -2 and 0. This is the reason that H2O2 can act as both oxidizing and reducing agent. H2O2 molecule is diamagnetic because O2 2- has got 18 electrons and no unpaired electrons. Oxygen is paramagnetic due to presence of unpaired electrons. Here H2O2 in -1 oxidation state gains 2 electrons, 2 oxygen atom gains 2 electrons and form oxide ion. So this shows oxidizing property of hydrogen peroxide. H2O2 plus 2Ki reacts to form 2KOH plus iodine is liberated. It has oxidized iodide ion to iodine. Sodium sulfite is oxidized to sodium sulfate with H2O2 very easily. Ferrous sulfate gets oxidized to ferric sulfate by hydrogen peroxide in acidic medium. Potassium ferrocyanide in acidic medium gets oxidized to potassium ferricyanide plus K2SO4 plus water is formed. Chromium hydroxide reacts with NaOH and hydrogen peroxide to form. Chromium hydroxide is green precipitate. It changes to sodium chromate, which is yellow coloration, plus 8 water is formed. K2Cr2O7 plus H2SO4 plus 4 H2O2 gives chromium peroxide, which is blue color solid, plus K2SO4 plus 5H2O is formed. Benzene, when treated with Fenton's reagent H2O2 and FeSO4, we get phenol plus water. Formaldehyde can easily get oxidized by hydrogen peroxide in alkaline medium to form formic acid, and hydrogen is liberated. On account of its oxidizing nature, hydrogen peroxide acts as bleaching agent, insecticides, and disinfectant also. It also forms addition inorganic compounds, that is coordination compounds. Hydrogen peroxide get associated with ammonium sulfate, sodium sulfate, global salt, which contains 10 water molecules. So one of the water molecule has been replaced by hydrogen peroxide, which will form coordinate bond. Sodium metaborate is coordinate bonded with hydrogen peroxide and 3 water molecules. Urea is coordinate bonded with hydrogen peroxide. When these addition compounds are dissolved in water, H2O2 is liberated. Acidic nature of hydrogen peroxide reacts with sodium hydroxide or sodium carbonate to form Na2O2 plus water plus CO2. Both the hydrogens are being replaced, it means it is dibasic acid. Barium hydroxide reacts with anhydrous hydrogen peroxide to form barium peroxide plus 2 water is formed. For hydrogen peroxide, remember the following relation. This will help you in numerical problems. If you want to find out strength of hydrogen peroxide in percentage, 17 by 56 into volume strength, that is, suppose it is 10 volume, so it will be 170 by 56, that is 3.03%. So volume strength can be found out by multiplying it with percentage. 56 by 17 into percentage. If I write 3.03, we will get volume as 10 volume. Volume strength of hydrogen peroxide can also be obtained by multiplying 11.2 with molarity. Normality 5.6 into normality. Normality of hydrogen peroxide will be volume strength divided by 5.6. These are shortcut ways. Molarity, volume strength divided by 11.2. For example, 10 volume divided by 11.2 will give 0.85. And normality will be 10 volume over 5.6, that is 1.7 normal. Strength of H2O2 in grams per liter will be volume strength into 68 divided by 22.4, or volume strength into 34 divided by 11.2. Both have same formula. Strength in H2O2 in grams per liter, if normality is given, so normality into equivalent weight, which is 1734 by 2 because it's dibasic acid. Molarity into molecular weight, that is 34.